In this demo, we're going to use Amazon Forecast to predict the sales for products from an online retail store. The dataset we're using is the Online Retail 2 dataset, which is available from the UCI data repository. This Online Retail 2 dataset contains all the transactions occurring for a UK-based online retail between the 1st of December 2009 and the 9th of December 2011. The company mainly sells unique or occasional giftware, and many of its customers are wholesalers. Here we are in the Amazon Forecast console. This is the dashboard where you can see all of your dataset groups, which is how Forecast organizes your forecasts. Let's go ahead and create a new dataset group. We start out by giving the dataset group a name. Then we need to choose a forecasting domain. A domain specifies a predefined dataset schema for common use cases such as retail or inventory planning. If there isn't a domain that matches your business problem, then you can choose the custom domain. Since this is retail data, let's select retail. To perform a prediction, we need to have at least one set of time series data. For retail, this data must include the item ID, timestamp of the transaction, and the demand. Before we go any further, let's look at the dataset we're using. If you were to grab the Online Retail 2 dataset, you'd see that we have columns for invoice date, invoice, stock code, description, quantity, price, customer ID, and country. I've done a little bit of pre-processing here and cut down the number of items that we're processing here, so we only have a single stock code, 21232. I've restricted to the country of the UK, since most of the orders are actually UK bound. Then what I've done is taken the individual order items and generated a daily total, since that's what we're trying to predict. One thing to note is the order of my data is invoice date, stock code, and quantity. If I go back to forecast, I can see I have a data schema which is item ID, timestamp, and demand. So we're going to need to move the timestamp before the item ID. We need to give our dataset a name, so let's call it Retail DS. The last thing to note is the frequency of the data is set to an interval of 1 day. Now that we've defined the schema, we just need to import the data itself. For this, we need to give an import name, so Retail DS import. We need to specify the timestamp format. If you remember, the timestamp format is in year-month-day. So let's go change that. Then we need to specify an IAM role that can access the S3 bucket where the data resides. And finally, we have the data location, which is an S3 bucket. I've already uploaded my data as a CSV into that location. Once the data is imported, we will be able to train a predictor. Once the predictor is trained, we can use it to generate forecasts. It will take a little time for the data to be imported, so let's fast forward a little. Now we have our time series data loaded, we can go ahead and train a predictor. To train a predictor, we need a name. We need to decide the forecast horizon for the predictor. We will set this to 90 days or approximately 3 months. Our forecast frequency is set to 1 day to match the dataset. For our algorithm, we can select AutoML, which will let Amazon Forecast choose the right algorithm based on the data, or we can manually select it. I'm going to go ahead and manually select an algorithm and choose Deep AR+. For our holidays, I'm going to select the UK calendar, and I'm going to leave the rest as the defaults. It's going to take about 30 minutes to train the predictor, so let's pop back then. Once the predictor has been trained, we can generate a forecast. Creating a forecast is fairly straightforward. We need to give the forecast a name and select the predictor we want to use. Optionally, we we can select up to 5 quantile values. Amazon Forecast generates 0.10, 0.50, 0.90 and 0.99 and mean as a default, which is great for our demo, so we'll leave it like that. Creating a forecast is going to take about 20 to 30 minutes, so let's pop back when that's done. Once a forecast has been created, we can perform a lookup. We need to specify which forecast to use, and then a specific date range. The start date needs to be before the end date of the data we presented the predictor. The end date cannot be later than the event horizon we forecast. For example, if we created a 90-day forecast, we can have a date range that includes up to 90 days from the data set we provided. If we selected only 30 days, then the forecast range would be smaller. We're going to look up a particular product, so we specify our item ID and then the value, and then we hit Get Forecast. You can see here that we've got the forecasting that includes the demand and then the predictions moving forward. The chart shows P10, P50 and P90 values. In this demo, you saw how to create a retail forecast with Amazon Forecast. That's it for this demo. We'll see you next time.
Hi, welcome back. This is section 1, and we're going to introduce computer vision. Computer vision is an exciting space in machine learning. You can think of computer vision as the automated extraction of information from digital images. Using computer vision, machines can identify people, places, and things in images with an accuracy that's at or above human levels, and with greater speed and efficiency. Computer vision is often built with deep learning models. It automates the extraction, analysis, classification, and understanding of useful information from a single image or a sequence of images. The image data can take many forms, such as single images, video sequences, views from multiple cameras, or three-dimensional data. Computing power and algorithms have advanced over the last 10 years. This has led to an increase in capabilities and easier access to computer vision technologies. So how is computer vision being used? Here are some of the primary use cases for computer vision. You can use image and facial recognition to improve public safety and home security, or as a way to authenticate access to personal devices. You can also use it to automatically classify images for content management and analysis. Autonomous driving is partly enabled by computer vision technologies, and so are safety features of cars, such as lane detection or collision avoidance. Medical image analysis with computer vision can improve the accuracy and speed of a patient's medical diagnosis. This can result in better treatment outcomes and life expectancy for the patient. And finally, in manufacturing, well-trained computer vision is incorporated into robotics. This can improve quality assurance and operational efficiencies. These are just a few examples, and you can probably think of more. Computer vision problems can be broken down into a few areas. Content recognition is about identifying things in images. It's a classification problem, but it's a complex one with several layers. In the picture here, what's represented? Is it breakfast, lunch, or dinner? Would the classification only be food? The answer depends on what model you use to perform the classification. Models must be trained, and the training data provides the algorithm with data for it to learn from. Say that you have a model that was trained with pictures of different types of food. You might expect the image to output categories such as milk, peaches, mashed potato, chicken nuggets, and salad. If you trained the model with different images, it could classify objects as tray, cutlery, and napkin instead. When you work with images, you might want to know what kinds of objects are in the image and the location of those objects. Object detection provides the image categories and where the objects are located in the image. There's a set of coordinates defining the location of a box surrounding the image, which is known as the bounding box. Bounding boxes for detection are typically top, left, width, and height coordinates surrounding the images. You can use these coordinates in your applications. When objects are detected in an image, there's a confidence number usually associated with that object. This percentage indicates the probability that the object belongs to a specific class. This confidence level is important when you want to determine an action that's based on object detection, especially in facial detection applications, or cases where the action has significance. Object segmentation is also known as semantic segmentation. It's like object detection, but you go into more detail to get fine boundaries for each detected object. Basically, it's a fine-grained inference for predicting each pixel in the image. Some applications that require object segmentation include autonomous vehicles and advanced computer-human interactions. Though object segmentation is a key problem in the field of computer vision, we won't be covering it in this course. Video adds another dimension to computer vision. With video, you get more data to work with, so you can capture the movement of people or objects, which are referred to as instances. For example, you can detect people who enter and leave frames, and also deal with moving cameras. Here's a use case for computer vision. Building on detection and tracking, you can analyze shopper behavior in your retail store by studying the path each person follows. If you use face analysis, you can understand other details about shoppers, such as average age ranges, gender distribution, and expressed emotions without identifying them. Here's another computer vision use case. You can also analyze images to identify actions using the motion in the video. For example, activities such as delivering a package or dancing. Looking at this image of a baseball player, some examples from the image could include capturing the batter's accuracy, the pitcher's pitching style, the type of pitch, slow ball, slider, and others, the inning, and the batter's performance versus the specific pitcher. Managers could use all that data to coach players on how to improve their performance, and they do. Coaches can also use the data during the game to make game time decisions. Say you want to initiate various actions based on the speed of the baseball leaving the bat and its trajectory. A hit that's calculated by an ML model could lead to an audio or visual warning about a possible foul ball into the crowd. Or it could result in a preemptive alarm that a hit has a high probability of being a home run. This means that events following a home run could be both well-timed and automated, such as playing music or setting off fireworks when the home run is hit by the home team. To wrap up this section, here are some key takeaways for this section. First, we covered how computer vision is the automated extraction of information from images. You can divide computer vision into two distinct areas, image analysis and video analysis. Image analysis includes object classification, detection, and segmentation. Video analysis includes instance tracking, action recognition, and motion estimation. Thanks for watching. We'll see you in the next video. Welcome back. In this section, we'll explore image analysis in more detail. And in part 2, we'll take a closer look into video analysis. To start, we'll introduce the main Amazon service we'll be using, Amazon Rekognition. Amazon Rekognition is a computer vision service that's based on deep learning. You can use it to add image and video analysis to your applications. There are many uses for Amazon Rekognition, including creating searchable image and video libraries. Amazon Rekognition makes both images and stored videos searchable, so you can discover the objects and scenes that appear in them. You can use Amazon Rekognition to build a face-based user verification system, so your applications can confirm user identities by comparing their live image with a reference image. Amazon Rekognition interprets emotional expressions such as happy, sad, or surprise. It can also interpret demographic information from facial images, such as gender. Amazon Rekognition can also detect inappropriate content in both images and stored videos. And finally, Amazon Rekognition can recognize and extract text content from images. Before we go further, here's a quick note on security. You need to check if the applications you build using Amazon Rekognition fall under any regulatory restrictions as defined in your field or country. Security and compliance for Amazon Rekognition is a shared responsibility between AWS and the customer. For more information about this topic, see the AWS compliance page. Amazon Rekognition is an AWS managed service. With a managed service, Amazon hosts the machine learning models, maintains an API, and scales out to meet demand for you. You can benefit from a set of models that constantly learn and improve. Also, you can focus on building applications that use the API and optionally training the service to understand your unique business needs. There are various resources you can use to access and interact with Amazon Rekognition, such as APIs, SDKs, and commands for the AWS command line interface, which is also known as the AWS CLI. The languages supported by the SDKs include JavaScript, Python, PHP, .NET, Ruby, Java, Go, Node.js, and C++. Finally, Amazon Rekognition integrates with other AWS services. For example, if you need storage, you can use Amazon Simple Storage Service, or S3. For authentication and authorization, you can use AWS Identity and Access Management, which is also known as IAM. This diagram illustrates an image search feature where users can take pictures and get information about the real estate properties they're viewing. First, the user takes a picture with their mobile device. The user then initiates a search, which causes the application to upload to Amazon S3. S3 is configured to call other services when a write event occurs. In this case, the bucket passes the S3 path of the new object to AWS Lambda. When the Lambda function is called, it uses the Amazon Rekognition SDK to call the service. Amazon Rekognition analyzes the image, detects aspects of the property, creates labels, and passes the information back to Lambda as an object formatted in JavaScript Object Notation, or JSON. Lambda then stores the labels and confidence score in Amazon Elasticsearch Service, which is also known as Amazon ES. Application users can now identify aspects of a property using the objects that were detected in the image. In this example architecture, the system checks uploaded images for inappropriate content. Like the previous example, processing begins when the user uploads content. First, the user uploads an image to Amazon S3. Second, the S3 bucket is configured to call a Lambda function when an object is written to the bucket. Third, Lambda calls Amazon Rekognition via the SDK. Amazon Rekognition then analyzes the images for inappropriate content and sends the response back to Lambda. Fourth, if the content is appropriate, the content is approved. Fifth, if the content isn't appropriate, the content can be sent for manual inspection. And finally, if the content isn't approved, a notification is sent to the user. In this final use case, the system analyzes a video feed for sentiment analysis. First, an in-store camera captures video that's then sent to a back office or a cloud-based application. Typically, an application like this uses Amazon Kinesis to stream the video. Second, the application uses the SDK to send the video to Amazon Rekognition for further analysis. Visual sentiment is extracted along with other attributes such as age. Third, the discovered attributes are sent to Amazon Kinesis. Fourth, a Lambda function extracts the data from the stream. Fifth, The data is then written to S3. Next, the data is loaded into Amazon Redshift on a regular basis. And finally, tools like Amazon QuickSight can be used to generate reports from the data. Amazon Recognition is designed to integrate into your applications through the API and SDKs. API operations are provided for detecting labels, faces, recognizing celebrities, and detecting unsafe images. To perform a prediction, provide the service with an image object in Amazon S3 or upload a byte stream of an image. Images can be in JPEG or PNG formats. Amazon Recognition processes the image, performs the prediction, and returns a JSON object with the results. When Amazon Recognition performs predictions, it often returns multiple labels. Each label has a confidence level. This confidence level indicates how likely the label was found in the image. Like this example shows, labels can also have hierarchies. When you find instances of objects, you need to understand where the detected object is in the image. For each instance, the results from Amazon Recognition include a bounding box that contains the starting coordinate of top, left, and box dimensions of width, height. Like the example, you can use this information to determine the location of the detected object in the image. It's important to note that all findings contain a confidence score. You can use the confidence score in your applications to tune your response to predictions. With a higher score, it's more likely that the object was correctly labeled. That's it for part 1 of this section. We'll see you again for part 2, where we'll explore facial detection. Hi, welcome back. We'll continue exploring image analysis with a closer look at facial detection. Facial detection uses a model that was tuned to perform predictions specifically for detecting faces and facial features. Facial detection has many of the same features as standard object detection, such as a bounding box or the coordinates of the box surrounding the face that was detected. This will include a value representing the confidence that the bounding box contains a face. There will be a list of attributes if found, such as if the face has a beard or if it appears to be male or female. There will also be a confidence score for these attributes. It can also detect physical emotions, like whether the person is smiling or frowning. It's important to understand this classification is based only on visual clues, and so it might not represent the actual emotion of the person. Facial landmarks are components of the face, such as eyes and mouth. Typical landmarks also include X and Y coordinates. Quality describes the brightness and the sharpness of the face, and pose describes the rotation of the face inside the image. Again, confidence is a feature here, and it's provided for each detected feature. And remember, the feature prediction is based only on visual observations. With Amazon Recognition, you can compare 2 images to determine if they contain the same person. Comparisons require both a source and a target image. The results will include all the faces that were found, and they include information about matching and non-matching faces. Again, confidence scores indicate how likely each prediction is. Amazon Recognition can also search for known faces. To use this feature, you need to train the model by providing a collection of images to use. After you train the model, you can then detect those people in images you provide. To find known faces, first create a collection and add faces to the collection. Amazon Recognition will perform facial recognition on the images you provide. It will then return typical information like the bounding box coordinates or the confidence score. To associate faces with an image, specify an image ID in the external image ID request parameter. This could be the file name of the image or another ID that you create. After you create your collection, you can then use the Search Faces by Image operation to search for faces from the collection. The returned data contains an array of all faces that matched. The information includes bounding boxes, confidence scores, and the external image ID value. You can then use this ID value to link back to the source image. Now that you've learned about the facial detection features of Amazon Rekognition, here's a summary of the guidelines we've discussed so far. When Amazon Rekognition detects a human face, it captures a bounding box that shows where the face was found in the video. It can also detect attributes such as the position of the eyes, nose, and mouth. It can detect emotion, the quality of the detection, and any landmarks that might appear. All these items will have an associated confidence score. A higher score means that the model has greater confidence about the detection. Gender is inferred from the image, not inferred from identity. Similarly, emotion is also determined from the image, and it might not reflect the subject's actual emotional state. How should I apply facial recognition responsibly? Facial recognition should never be used in a way that violates an individual's rights, including the right to privacy. It should also never be used to make autonomous decisions for scenarios that require a human being to analyze them. For example, suppose that a bank uses tools like Amazon Rekognition in a financial application to verify their customers' identities. The bank should always clearly disclose the use of the technology and ask the customer to approve their terms and conditions. For more information about this topic, see the AWS webpage about the facts on facial recognition with artificial intelligence. We'll now explain how you can use Amazon Rekognition to process videos. You can perform video processing on both stored videos and video streams. Stored videos should be uploaded and stored in an S3 bucket. Each type of detection has its own start operation. You can search for people, faces, labels, celebrities, text, and inappropriate content. Amazon Rekognition publishes a completion status to a topic in Amazon Simple Notification Service, which is also known as Amazon SNS. Then, SNS can route these messages to subscribers. For durability, it's a best practice to route messages to a message queue in Amazon Simple Queue Service or Amazon SQS. Your application should monitor the SQS queue for completion. Each start operation has a corresponding get operation for retrieving the results. If you call get detection results, it returns an array of labels that contain information about any labels found in the video. The label information includes the same labels as image detection, but it also includes a timestamp of where the label was detected in milliseconds from the start of the video. In addition to stored videos, you can also use Amazon Rekognition Video to detect and recognize faces in streaming video. A typical use case for this is detecting a known face in a video stream. Amazon Rekognition Video uses Amazon Kinesis video streams to receive and process a video stream. The analysis results are output from Amazon Rekognition Video to a Kinesis data stream. They are then read by your client application. Amazon Rekognition Video provides a stream processor that's called Create Stream Processor, and you can use it to start and manage the analysis of the streaming video. To use Amazon Rekognition Video with your streaming video, your application must implement these resources. First, you need a Kinesis video stream to send streaming video to Amazon Rekognition Video. Next, you need an Amazon Rekognition Video stream processor to manage the streaming video analysis. And finally, you need a Kinesis data stream consumer to read the analysis results that Amazon Rekognition Video sends to the data stream. If you want to find a face in a video, you need to create a collection.